crítica concreta,
Yeah, I think that's it.
So I'm giving you a class, a lecture about earth construction, okay? First thing, everyone asks why use earth construction, why use earth? Because you have it everywhere, okay? So if you have the earth there, why not use it? So it's local, it's natural, it's sustainable, recycled, used, all of that. And healthy because it breathes, it has a lot of different characteristics, which is very good. And if it's well used and well planned, it will be economical. So just for you to understand, I came with the two graphics just to show you about sustainability. We talk about normally energy, incorporated energy. This is two of the things that we talk about, and potential for global warming. So you can see this is type, it's rammed earth. So this is how much it takes for global warming. And you see here is concrete, steel. This is burn brakes, okay, and all of those. And this is wood, and this is granite. So this same over there. So as you can see, it's very low. So, yeah.
Sorry, what kind of bricks?
These bricks here, burn bricks.
Burn bricks.
Okay? Because when I talk about earth, I'm talking about earth without any burning. It's a natural one. It's raw earth. Okay? So when you talk about earth construction, what you think is the first layer, not going to use it. You use the first layer is a organic layer. That is not earth. When I talk about earth, that is not the earth that I use for construction. What you use for construction is the deeper layer, normally around 16 centimeters, 1 meter, but normally 16 centimeters is enough for you to get the earth that is good for your construction. It cannot have any organic materials, okay? So what is earth? Earth is stones, it's gravel, it's sand, it's silt and clay. What is the difference between them? The size, okay? So the clay is the smallest one, and the good thing about the clay is the one that makes the bounding of the particles, and also is the one that works with the water and makes the breathing that normally I talk about, makes your walls breathe and all of this, and takes all the smells from the air and all of that. So if you normally what you need is to understand all this skeleton of the earth, and then understand how it works with plasticity, compression. So this is how you control and you understand earth. You make some tests. Okay, so you need to understand the characteristics. Here you can see it has different kinds of, you have different kinds of earth. Can be different textures, different colors, which is really nice for you to enjoy as an architect. For understanding, there are different kinds of tests. You can do it on the site, which are very easy, by testing, by feeling it, by the vision, like the sizes. Sometimes there are some people that in the old days would put it in the mouth, and even with the taste they could understand the kind of earth they had, okay? I'm not going that much. So that there are different kinds of testing on site, and then you can go to the lab, okay? And make more into the characteristics of the earth. Mostly, normally what we want here is to understand how our clay behaves. That is the most important part, okay? And then we go to the construction. In the construction, earth can be used in very different techniques. What we have here is load-bearing constructions that we can use. So from digging, from filling, from stacking that is cob, we talked about, rammed earth, which use just ram inside the box. Then you have the blocks, okay? So here is big walls that you use. Then you have the bricks. There are different ways of making the bricks. You can press it, you can compress it with a machine, hand machine or others. You can cut them, and then come the machine.
Extrusion?
Yeah, extrusion, and then adobe, handmade, and all of that. And then you have the supporting. So the supporting structures, it means it's a mixture, a mixed construction. Normally you have a support, and then you fill with earth. Okay. So again, there are different ways. In the world, you can see, just for you to understand, this is where you have earth construction in the world. And you can see it's almost everywhere. So where you can find earth, you can use the earth construct. Because of yesterday asked the question, I came with this. This is old city of Saana in Yemen. It's 2,200 years old, and it's like I said, 9 to 14 meters. Okay, this is not the biggest one. Here is the Manhattan from the desert, and you can see how high they can go. Okay, so this is adobe construction. It's bricks, and they go on. What that means is you have very big walls in the base, and then it goes thinner up. That's why also they go like this.
Is it calculated? Do you know if
By
it's
the
like,
men, they know.
Okay, but like, is there like a let's say hard science like guidebook where you can go and say like measure like that's the?
That I don't know. I haven't studied this, but this comes from the knowledge from years and from generation to generation. Then I come with some topologies and see how Earth can be. You saw there in Yemen that kind of construction. Here in India you have this. This is our just three kinds of Earth construction, traditional construction, which are with Earth in India. And you can see they are very, very much different, and they can be really beautiful. Okay. And in Portugal, you are in Portugal, so I'm going to talk about Portugal. So what is going to change with the earth construction is mostly the characteristics of the earth, of course, so geological, but also topography and rainfall and the climate, and then of course, seismics. So all of this will change the kind of technique you're going to apply and the way you make your own house. So the characteristics of the architecture of the house, of the building. In Portugal, you can find rammed earth in the south, okay? Then the bricks, which are adobe, you normally find it here. This is an area where you don't have any stone and you have rivers. So adobe needs a lot of water, okay? And normally it's used because they didn't have any stone. So the only thing they had was the earth that was there. So this is the area. As external walls, and then you can find some places the internal walls also in adobe. And then you have water and adobe. It's one of the mixed constructions that I showed you. It's a wooden structure that then you filled, and that one is the one that you're going to find in these walls here. Okay. Even though this is showing only this area, that one there means that is an area where you can find earth, a clayish earth. Okay. And so this map is only showing the clayish earth, which is earth without adding anything. But the truth is, you can find all over the country water and adobe earth construction, but earth, it's sandy earth. They normally mix it with lime, okay? And that one you can find everywhere. So Watton and Dove, so I'm going to show you some of them. Watton and Dove, this is it. So here you can find, it's a clayish because it has fibers, okay? Normally you have the wooden structure that is behind, then you have this wooden here, and then you fill it, and then you make the final plastering there, okay? No, okay, go. Just for you to see, Porto is a World Heritage from UNESCO because of the presence of Watton and Dove construction, okay? This was in 2000, it's a project between 2012 and 2017. The problem is with all this construction that is happening here, what Hugo showed you yesterday, that normally you go inside and if you really know how to look at things, you don't need to tear anything down. What is happening all over Porto is they tear everything down. So right now I don't know how much of this heritage we have, okay? Which is a shame. In the other hand, in Guimarães, in the north of Portugal, the city, the municipality had a project which was really good because they made a research to understand the techniques, and when they made the renovation of the city, they applied all the old techniques. So what you're seeing is a renovated city, old city, where they used all these techniques. And you can see this is stone, okay, so the first floor is stone, and then you can find water and Dove on the external walls. And then the interior walls are all with water and Dove. This is a technique that Portugal took to Brazil. So we went a lot of places in the world and we took some of our knowledge. And Pau a Pique it's the name that Brazilian people give to this kind of construction. And this is a picture of it. Okay. Then you have a dome. Okay. I show you some of them. This is a workshop that we did, but just to show you that in an area in Aveiro, we have adobe, this white adobe. It's made with a very sandy earth, but because they didn't have any stone, that was the only earth they had. So, but in the meanwhile, they have a lot of lime. So they always mix lime with the earth that they have, and this, if you go to that area, all the houses were made like this. This one here, I was telling you, there's no earth construction with organic earth. This is some exceptions, one of them. So this comes from mud taken by a lake in the area of Aveiro. So normally what they do, they use it, but they take it from a special place. So the guy goes to the lake. He chooses the place and he chooses by the plant. So he looks at which are the plants that are growing there. Where? Patera de fermentamos. So he looks at what kind of grass is growing, okay? And he says, okay, this is it. Then he cuts. He takes a few of them, makes 2 or 3 adobes, leave it there, and comes back a week later. Looks at them and says, okay, this is not, this is good. So this is the one that I'm going to use. And normally this adobe are used for storage rooms, so building that they are not for living, okay, for animals, this is an area of fishermen, so for storage for the boats and all of that. Just to show some of the traditional architecture, again, different kind of architecture. So this is adobe construction. different, very much different way of making the architecture in this city, in this area. It has to do with the kind of material that you're using and also how people live in that area, okay? This is a row, it's in the area of everybody interior, okay? So it's people that live from agriculture. And the house goes around a patio, so it's called a patio house, okay? And you can see you have the house, and there you have all the area that is for agriculture and the animals and so on. So just to show you, in this area that we have adobe, you have more or less 4 types of architecture, okay? So you have block houses, patio houses, evolution houses, and elementary houses. Just to show you, you saw just the patio house there, then you have this is a little bit down in Gafanha, and then you go even down, this is in this area here, is a very different one. So this is Caramella, is evolution house.
How does it work with stone? Like, so you have like stone?
There's no stone there.
No stone?
Normally, in some places you have foundation made by stone, but because it's not good, it's you shouldn't use earth in the foundation. But sometimes you can, okay? But it's not the best way. So normally they make the stone foundations and then you go up and you make the earth construction, okay? Normally, yeah, A3-Ateliê, exactly. Tell me.
I was going to ask what was the window surrounds the basement?
No, how it's done. So you make the walls, and then only above you have timber, okay? But even though earth doesn't work with water, in this area we have wells, okay? And you can see here more than 100 years, and it's well. Why? Because it's a kind of lime that we have in that area, a dark lime, which if you mix with the earth, it lasts very much, it works very well with water. So also that, it's important to understand and show that it's not a risk, something that you cannot work with water and earth, you just have to know how to work with it. And this is water channels that you have. So normally these fields have a well, and then the water goes in above, okay? It's a channel that takes the water all over the field and uses for the agriculture. And in Goa, we have Portuguese winter, and this is 2 buildings that we have here made by Portuguese with a kind of adobe. This is cut adobe. Okay? You still have people doing this now. It's beautiful construction, and so another kind of adobe that you are able to see. And I just show you this because this is another one that we were able to resgatar, save. It's no longer there. No one is doing anymore. The one that I showed you, it's not happening in Portugal. Okay, no one is doing water and adobe. No one is doing adobe anymore. I'm trying to make this happen again. Okay, but this one is a adobe that is cut. It's called turrão, and they cut again from it's near a river in the area of Aveiro. This river is an area for salt production, okay? And normally they would make the walls that make the division from these fields of salt with this thing. So they go there, again they choose, is a kind of herb, plant that grows there. He goes there, he cuts, and what happens is the roots are there. They take it, they make the wall, and it doesn't work just like the brick. The plants will grow, the roots will grow, and that becomes a unique thing, okay, united thing. So it's really beautiful to see. And what is happening now, if you go by boat in those places, no one is doing this anymore, and you see garbage and concrete and awful things just to make that walls happen. And then we Randolph. Randolph is the only technique that is still being used in Portugal. Here, like I said, you have a box, okay, and then you ram inside, and then you just go by layers growing up. One of the types of houses that you can find, this is from Alentejo, okay? Again, very different, but just for you to have an idea of the kind of traditional architecture that we have in Portugal. This is in the area of Alentejo and Algarve, more Alentejo, and it's very interesting. This is a traditional house, and this is an interpretation of the traditional house into modern architecture by Bartolomeu Costa Cabral, which is a beautiful project. And then you have different kinds of interpretations, okay? So this is modern projects by Portuguese architects, but they interpretate the traditional way of doing architecture. Again, this is the knowledge that comes from the past, how to work with seismic activity. So these are, we call it fortes, okay? A contraforte. I don't know how to say it in English. Buttress, okay. So this helps to the problem with seismic. You have horizontal forces and you have different movements, okay. So this is good for the horizontal forces, and don't take they don't open like this. Okay? But we have a lot of militar earth construction here, normally rammed earth. So this is a fort, it's an example. Why is this very nice? The ones that we learned this from the Arabs, okay? They entered the Portuguese territory, they went till the north, and then we conquered our territory again. But we learned a lot from them, and Randolph is one of the things. Okay? And the forts are one of the things that we learned from them. Why is this so good? The difference between an earth fort and a stone fort is you have those big balls that they throw to the castles. You know, I've seen this in the films. If a stone that goes there, it breaks. If it goes against a wall like this, it goes inside and it stays there. It doesn't do anything. Okay? So that's why it's so good for this kind of construction. And this is some Portuguese architects that made some different kinds of experiments and different forms and different architecture, which is really nice. This is from Plano B, earthen columns. This is it's a social project. They wanted a place a community. They wanted a place to be around people and enjoy. So they made columns. This is in the middle of pine forest. So the idea is to make the columns like the pines trees, okay? And then you make a roof, okay? And this is very nice. A beautiful exhibition in the gardens. And unfortunately, it was done and then damaged. It's not there anymore. And then you have the mortar. So I've been showing you the load-bearing construction, but then you have earth used also as mortar and plastering. So again, I'm showing some examples. This is in the north of Portugal, Trás-os-Montes. And this is clayish earth, so this is the finishing, only with earth, and has some straw. In some places, they also use the lime mixing. just because it's external plastering and it's better for the humidity and long lasting. Okay.
How do you maintain it?
If it starts to crack, they go there and they make the finish. So this needs some maintenance. Yeah. If you use the lime, it doesn't need so much. Okay. But it works then very well. So it's very important to understand that earth construction, any kind of architecture, if you want to make a good and lasting architecture, you have to think that you have to protect and you need to maintain it. Okay. But as an architect, you should make the project thinking you want a long lasting. Don't think only as aesthetics, okay? You think like, okay, I can make aesthetic, beautiful, but at the same time it should long lasting. So a house that doesn't have a hat and doesn't have a boot, it will have problems. Even if you make it with concrete or anything else, it will have, okay? So the same thing with earth construction. You need a very good hat and a very good boots. Why? Because of water loss, of course. Okay. And this I showed you yesterday. So is the mortars and the floor. I talked about this. And there's an evolution. So those were traditional, but like any kind, anything by man, made by man, we've evolved. So earth construction evolved also. So type works very well, Randolph works very well because of compressed earth, so it gets very strong, but it's really big. From other hand, you have adobe, which is very nice because it's small, it's good, it's light, so it's very easy to work with. So the evolution was to mix the two together. Okay, and then from here you have pressed adobe, where they make the mold. You put the earth inside and you press it. This is one step. This was the evolution. But then they said, why not with a machine? I make it more compressed, okay, and then I will get that much. The same behavior as Randolph, okay? So that from there, compressed earth blocks came with the machines. So here is the difference. Dry soil, you have that much of density. When you compress it with a machine, okay, you go to that much, which is really, really different, okay? And this will help you to have different shapes of blocks. Again, very small blocks. You don't need even the bricks in the area of those houses that I've shown you. Those were 14 by 16. Were very heavy, very big. Okay. With this, I have small ones, very small. So I can make a house, a one-store, two-stores house, with a wall, load-bearing, only 20 centimeters thickness, okay? That is enough. So it's very important for this. Also, the resistance, of course, changes a lot, and the water resistance, because you're making the particles, the space between the particles are less, so the water, it doesn't have enough space to go inside, okay? So all this depends on the energy that you use to compress it, and it's very important to control the amount of water that you have in your mixture. So these two things are the main focus that you need to be when you're making your compressed earth blocks. Okay, so you have manual machines. This is mine. Then you have semi-automatics, and then you have automatics, and so and so and so. And with this you can have different shapes, which is really good because you can shape it, for example, to put some structure there to reinforce because of seismic beam, to also because of seismics is very important. If you don't want to use other solutions, you can very much make a beam with the block. If it has a U shape, you make a beam with a normal beam, concrete beam, and then it's there. Can go. Just to show you, this is one of the productions that I trained the guys and I helped them the first weeks, and then they continue. So this was made during winter. Of course, I need the dry land, the dry soil to make everything, so this couldn't be having any water, and also to work. So we were able to have a storage place that to make all this. And from here, just to show you some of the examples that it's beautiful, and it's modern architecture made by earth construction. In this case, by the office that I work with in India, it's Biomes in Bangalore. Okay? And with this, you can find this kind of environments, but it's very important because the static is there, but at the same time, you really have a natural and healthy environment there, because it becomes your third skin, like I was telling you yesterday. Oh, just go back. This is a house for a painter. I have another, in Portugal we have an architect who is a painter also, and both of them ask for earth house. Why is that? Because they work with paints, which have smells, which is not nice. With earth construction, if you work with this in an earth house, you don't have the smells, because the clay and the earth will absorb all those smells. Okay, so you don't feel that. So the environment is much nicer. It's much healthier. Okay. Different shapes. Okay. A living room. This is a school, a music school in out of view. This is in Bangalore. Japanese house made by, this is compressed earth blocks, but they mix with the ashes. Okay. So let me show you. Normally, compressed earth blocks it can be used with raw earth, but most of the time we mix with a little bit of concrete. Why? The good thing about compressed earth blocks is it's a material that can very much compete with the market materials. Why? Because it's easy to make and it has good behaviors. But the problem that we have is I need an engineer to make my project, and the engineer needs guarantees from the material. Okay? So the only way I have in small amount of time to tell my engineer that is how much my compressor blocks can help as a pressure or as a structure is with concrete. So the people that work with concrete, mixed with concrete, what happens is you need a specific kind of earth. So if you don't have that skeleton on the earth, you have to change it a little bit. But it's very important, don't ever go more than 7% of cement. Okay? If you go above that, it's no longer sustainable. It's no longer earth construction. Okay? So I know Brazilian, and there's a lot of other in US. They are using much more. They're going to 10%. If you go make the math, it's the same thing as making beams and concrete structure. So it's not load-bearing earth construction. Okay? And this is some of the examples, which I think is beautiful. This gained an award last 2 years ago. Okay. And about height, this is a water tank in Auroville, and that much. This is my scale. Okay, and this is a house from an engineer. This is not architect. This is an engineer building. Okay, but it's that much high, just for you to show you. And a healthy environment, beautiful. Okay, eco resort in India by Biomes, and fireproof. So it's everything good. It's the best one. So you should now think about making earth construction in your project. And I'll leave you with this sentence, which I think is really nice. Perhaps the most friendly, intimate material for man, from where he fits and her lives and protects itself and mingles with her. When in the earth it becomes as if returning to its origin. So, thank you very much. Yeah.
Is it a material that you can reuse? For example, if there is a wall of bricks of adobes, like when it's already mixed with 7% of cement, like,
Yeah.
is it something that we can after deconstruct and reuse for anything, or remix, or what about this?
That is a question that normally when I say I use cement in my compressor blocks, because it's a way of for me to compromise with the client and the engineers. In the earthen environment, this normally is not well seen because of that question. But it's possible, okay? What is happening is you have earth there, you almost don't have any cement mixing. You just mingle that and you use it again. What you need is to reuse, put again some cement there, because the cement is no longer the one that is there is not going to react anymore. Okay, the cement has one thing. The difference between lime and cement is lime will react with the water during the years and time, and it becomes stronger. So that's why you have 100,000 years old construction still in good conditions, okay? The most important thing is maintenance, but that comes with any kind of material, it's not only earth. When you go to concrete, when you go to cement, you need, the cement reacts with water, and in 28 days, it is higher performance. Then it's coming down, okay? So, everyone thinks, oh, concrete is the bad thing because it's durable. No, okay? We have 100 years of concrete construction, and most of the old concrete construction is in really bad shape. Okay, and you cannot reuse it because it's poured, is bad. Okay, so the difference is there. So you put a little bit of cement there with the mixture, you tear it down, you can use it again, you mix again, you put a little bit more and go on.
And why not using lime and not concrete, like in this mix?
Yeah, you can use lime. The problem with lime is lime needs water, and when we work with compressed earth blocks, the amount of water that you need is very less. So it's difficult to come to a good mix that makes the lime work well and performs well with this kind of construction. But it's possible, and we are able to make very good blocks, better or equal to the ones that you are able to do with concrete or the cement.
Can I?
Yeah.
When I recycle like with sugar lobby, what we do, instead of reusing totally the material, you just use 10% of the old material and add 90% of the new. And after,
Yeah.
so you little by little in the big building, you can recycle all, and also use other materials that are there, that are inert, like they don't react because the cement is already dead, and you can use it so you don't produce extra debris, but you incorporate little by little in your new building. And this way it disappears, but it's also you save material and
So if you
movement, transport of the material.
Yeah.
With the TIPA techniques, like, is it sometimes do you use structural stuff like adding fibers or?
No,
I don't know
with
anything.
renders you don't use anything. It's just rand.
Yeah.
The problem is you don't have engineers that have the knowledge to make that kind of structure calculations. Okay, so here in Portugal you have the engineers that were born in rendered houses. They live with rendered houses and they believe in it. So they are willing to sign and take the responsibility for it. Okay, but the other ones are not. So most of the renders that you've been made here, normally they have concrete pillars, and then you have the renders. But that is not supposed to be like this, because it doesn't work. Okay. Another thing that it's very important is materials have different behaviors. So the concrete moves in one way, the earth will move another way. So it never works. It will have cracks. It will have problems. Okay.
The main problem with the earth is that it's not like standardized, because you dig here and you dig there,
Yeah.
and it's always different. So you should make a study, but normally architects and engineering go for the fastest thing. And so what she was saying, a little bit of compromise, you close your nose and you put this 5% of cement, and magically the authority are eager and happy with it. So it's a little bit of a thing, but it's sad because really it's not necessary.
For example, just for you to understand, here in Portugal, for me to work with, one thing is India. Okay? One thing is another country. In India, I have the engineers that have the expertise. They were there making the research to come to this technology. They are in the process of the technology. That's why they are so good, and I love to learn with them. But here in Portugal, I don't have the expertise, and I need to be the one that gives the guarantee to the engineer and to my client. So what I do is, I go to the field, I look at the earth, I make my testing, okay, in the field. The one that I'm using in my project that I showed you yesterday, the Eco-Ria. So this is sand. I almost have 10%, 15% of clay. It's really interesting. This is from Aveiro. This is the earth that they use for the adobe. And it has less clay than this one. Okay? So that's why they use so much lime. So they really use a lot of lime, because there's no bounding for the material, for the particles, so they use but this is the earth that they have there. So this is the only thing that they have to work and build the houses, so that's why. And this one came from Coimbra. From a place, I was going on the highway and I saw excavating place. They were taking earth, and I was wondering what that was. I went there, and it was a place where they were taking earth and they were sieving it or washing it to use the sand for construction. Okay? After, if you come here, you can see that this is all clay. And that clay, they are not doing anything with it. It is staying there in the field. So it's incredible, the material, the rich material that you have there, it can be used in architecture with a beautiful color, and it's not using. And the amount of water he's using there, and the amount of energy that is being used just to wash, just to use the sand, it's incredible. And this is from Porto. Okay? This one is from Porto. So this is the kind of earth that they used in the watering dome, in these walls. Okay? And this is another from Moreira, a little bit different. And this is the clayish, earth that I found that they use for the mortars and the plastering in the area of the project that I'm doing in the north of Portugal. So this is the normal kind of earth that you can find, but they would have a little small place where they could take this, and from this they would make the mortars and the plasters. That right now it's not there anymore because someone made a house above it, so I cannot use this anymore.
Would that work for blocks?
For blocks has too much clay.
Okay.
Okay.
This one has too much clay.
Too much clay. Yeah. Because it's a clayish one. Okay. So this one, even though when I came from India I said, oh, I'm going to make earth construction, I'm in the north, and he says, oh, in the north there's no earth construction. I'm going to tell you the best blocks I made was with this one. Okay, the one that they say it's impossible to be used because it has normally around 20% of clay, which is the best amount for compressed earth blocks and rammed earth. The thing between compressed earth blocks and rammed earth is that rammed earth needs stones, or what I'm saying is the skeleton needs bigger particles. When you go to compressed earth blocks, you use smaller ones. Okay. So I'm gonna make an exhibition here. You can look at things and feel what means to work with earth. Okay.
I have one question about round earth and like controlled erosion of them. Could you tell us a bit more about this? Like how when you put layers to control the erosion and for its maintenance and so on.
To control the erosion.
Of the round earth wall.
Yeah. So I'm not sure if I understand when you should. Yeah. So the erosion, you say if a wall takes the water, and so every earth construction, of course, if it's not like the wells that we've seen with that kind of line, the water, if goes there, it will make erosion, of course. So every traditional earth construction always has plaster. Okay? The only construction, architecture that doesn't have plaster is the modern one because the architects want to enjoy the textures and the colors of earth. Okay? It's okay, no problem, but you need to protect it more, okay? And it will always come something out. So it's impossible to avoid it unless you have protection. It's the plaster, okay?
You use rammed earth, before they used like rammed earth as a structure, and after this plaster was the part you sacrificate each year to the elements, and after the next year, little by little, you just replaster the part that. So
yeah, that was there in the culture.
Yeah.
Okay, so it's very interesting because, like we were saying, that this takes the installation that you're going to use takes a long time to dry. The earth is the same thing. Okay, so it's interesting because with rammed earth or double houses, you have 15 centimeters thickness of a wall that need the water there to make the mixture and to work it to make it there. So that water has to come out. Normally that would take a year. Okay, so normally they would make a house. If it's this kind of construction are community constructions, they would come, everyone would come together to make the house of a new couple, okay? They would make the house, and after a year, they would make the plastering. Okay, so that during that year, the wall is reading and it's drying. Okay, and then after they would make the plaster. So again, it's a festivity around the house.
Of course, that's difficult
to work with now. So
no,
that's why
of course, because people normally want the house to yesterday.
Yeah. So that's why the architects like to just leave it like this. Okay. Or you make a plaster that you cannot use a plaster with the synthetic paintings or any of this. You have to leave it dry. You need to leave it to breathe. So that is important. So again, you need to think a different way, okay? And talk with your client also to understand this process. This is a process, but it will lead for much better quality of life. that is certain.
What ingredients do you put in the plaster to make it waterproof?
Oh, there are many. Okay. So in Portugal, normally what I've been seeing is only lime. Okay. But if you go to tropical areas, you can find a lot of plants that are used to mix with earth. Okay. Cactus. I don't say. Moisture. I don't know. Yeah, baba is that. So you go around the world, men were able to come with so many different solutions that they use what they have. In Portugal, we have lime, we use lime.
All right. Thank you very much.
Okay. I came with something that yesterday we talked about lime. I don't know if we're going to be able to see this, if we're going to use the somewhere. So I came with, this is the lime that I told you. This was a stone lime mixed with the water, and it already burned. And right now this is called lime pasta, okay, which is really good for plastering. Okay, with this you can also make paint. Okay, and the water, if you can use water also for very good insulation, mixing with materials. Okay, so this is very interesting because this thing is only water with lime, and the longer it stays there, the better it becomes, because the reaction between lime and water is always happening, and it's getting better and better. So if you want to try it and see what I was telling you about.
And for example, all these ceilings are made with that.
Yes.
Not only that,
Yeah.
but parts of it.
So I had some in my house, so I brought you this.